sharing my screen. Okay, so good evening, everyone. We are going to be discussing, like we mentioned in the last class, NumPy. Yes. So we want to start Jupyter Lab. Okay, let's start. We are going to start another start test. NumPy dates. Right. So introduction. Then we make this a markdown. So, to speak briefly about what NumPy is just, in short, it's just an alternative to what we have, what at least in Python. So, and then when we talk about NumPy, we talk about matrices. We talk about matrices. Okay, not the movie now. We talk about matrices, and then for a lot of us, we know what matrices are. When we talk about matrices, we talk about stuff of this sort, having rows, and columns. So in this matrix we have, this is a 3 by 3 matrix. That is, we have 3 rows and then 3 columns. So it's the same idea with NumPy. And then why do we have to discuss NumPy at all? We are discussing NumPy because it also helps us in data analysis to manipulate data. So you want to perform certain operation, you find yourself performing some mathematical operation, which is NumPy you use, because you might be crunching or have to do with a lot of number or large files. Some numbers might have thousands of records. It's going to be very expensive, or your operations are going to be very slow to perform if you perform those operations using a list. So you use NumPy in place of a list when you are doing data crunching and data analysis, because NumPy is extremely fast compared to a list. So just like we did for pandas, we are going to be learning about methods in NumPy. So of course, to install NumPy, you do pip install. So installing NumPy, installing NumPy, we do pip install, do pip install like we have always done. Then you run it. Then we see that NumPy is already installed for me, and then which means that is satisfied. And then now we can then import it and use it in our notebook. And then for pandas, we import pandas as PD, but NumPy we import NumPy as NP. It is conventional in Python and data analysis. So moving forward from there, we have discussed at the basic level what NumPy tries to do is a faster alternative for data crunching or manipulating composite objects in Python. it is extremely fast compared to this. So and then we have also mentioned that the basic or unit data structure that NumPy acts upon is matrix, or you can call it a scalar because that's one dimensional. So every data you pass to NumPy processes the data as a matrix. So let's say we have a one-dimensional matrix. And how do we get a non-dimensional matrix? Have a data that is A, then you see NP array, and then you pass a one-dimensional matrix 1, 2, 3, and then you have this, and then you can check this by saying let's print A and see what A looks like. This is your one-dimensional. If you ask me, this looks somewhat like a list, but this is not a list. So this is one-dimensional matrix in NumPy. Now I want us to pay attention to the methods we are using and then how we are using the methods. And of course, after this class, this file is going to be available for sharing. So now this is a one-dimensional matrix, and we see that in this matrix we have just integer numbers. So for efficiency, to make sure that our number or our NumPy operation is even faster, we can go further to define the kind of elements that we have in our array, and then we can say the type, data type is going to be an int 8 or 32. So let's say int 8, and then I can run this, and I can print 8 to the screen, and then I've declared the int. Now operations that we can get perform on this is, then we can say we want to find out what the dimension of this is. Get dimension, and how we do that here is a, which is our data dot ending, then this will give us the dimension of a, and then we say that the dimension is 1. So if we say define another array that is two-dimensional, and then it's going to be like this. Two dimension is going to be, it's going to have 2 rows, right? There's going to be, we can say 1, 2, 3, comma 4, 5, 6, and then we can print this like we did for A. We can print this like we did for A, and then we say that this is two-dimensional. And of course, I can say we always do A, then we can say this is B, I say this is B, then we can run this again. So we see that A starts from here, and then this is B, and then we see that this is two-dimensional because this is row 1 and then row 2. So if I go ahead and check dimension for B, I say B dot ending, see that B is going to be 2. Okay, let's do this in differentials. Still 1, and then B is going to be two-dimensional. So that's how we get dimension for in NumPy. Now let's go to getting shape. We know for every matrix has a shape. How to get shape, and then how do we, what is the shape of matrices? Matrices are defined in rows and column. The row comes first and then the column follows. So for this, it's going to be the number of rows number of rows, shape is row comma column. You can just write it in full, row comma columns. Then how do we get the row? So for a, we can get row by saying a dot shape. Then once I run this, we know a is one dimensional, so is one. How many rows do we have in here? We have one row and then we have 3 columns. We should get something like 1 comma 3. Let's do for b. Exactly. So and then we know that for b we have 2 rows and 3 columns, so this makes sense. Now another thing that we can do for with our NumPy now is to get size of our data. And how we do that is almost the same thing as what we've been doing. It's going to be a dot item size. Then we can get what the item size is. This is 8 bytes. And then we can get same thing for b, 8 bits, sorry, it's 8 bits. And then that makes sense because we have declared the int to be int 8 here. So let's assume we have a data that is c, and then we declare array, and then say it is even one dimensional like we've had, but this is going to be data type equals to int 32. I think we have 8, we have 16. I think that should be int 16. Let's check it out. And then now we have c, run this. And let's see, we get a item size. See what this gives us. What we'll get into. I'm not sure if that is correct as well. 4. Okay. I doubt that you ever need this, but I don't know what's going on with that. So essentially, this is introduction to NumPy, but there are more interesting stuff to do with NumPy. And what are the interesting stuff? So you have to understand that for this to make sense, because now you're probably thinking this is like mathematics, what are we doing? We have worked with pandas, and then to put this in a quick perspective for us, we understand that I'm going to go to a previous file that we have worked with in the past, and then that's going to be a pandas file. We have interacted with a CSV file, and then we know in a CSV file we have rows and columns like this. So usually in data analysis you are dealing with quantifiable data points. For instance, you want to if you have to use this type of file, one of the desirable column will be item width. The reason being that it has numbers, it is quantifiable. And for columns which are not quantifiable or numeric, you find a way to either change them to numeric value. You can say fdw58 could be mapped to 0, and then 14 could be mapped to maybe 2, or you could say fdw58 could be mapped to 58, fdw could be mapped to 14, and so on and so forth like that. Because it is numbers that you want to use, you can run analysis on to generate quantifiable outcomes. You can run some statistical models on to get quantifiable outcomes, which is why usually in a file like this, of course you have your headers, but most of the values in your file are going to be numbers. So to convert those things into numbers, that is what we call data cleaning. So there are various ideologies or ways to go about it. So at the end of the day, you take a file, like you start work with a file like this, and when you are done, everything looks like number. And then there are legends to interpret what each of those numbers mean. And then you can then run just for places where you have to do some mathematical operations or some statistical operations. You can then use NumPy, because NumPy is going to see each of these as rows and columns. So it's going to see it as a matrix. So if you have, just like we have here, a 5681 rows by 11 columns, you know that that is going to be a very large matrix. So what we are working with here is just like a subset of what we'll actually have to work with in reality. So that is why NumPy makes sense. And then we know, based on our discussions in the last previous classes, what pandas does, and then we are getting to know what NumPy does. They have clear path, and then they have specific and um, specific uses, but they go hand in hand when it comes to data analysis. Okay, so now let's get to other interesting stuff. So let's talk about assessing slash changing specific element, rules. So how do we do this? So again, we have a matrix A, and then it's a 2 by say 2 by 7 matrix. So we have 1, 3, 4, 5, 6, 7, comma 8, 9, 10, 11, 12, 13, 14. But of course, this has to be in the same matrix, so this has to be bounded like this, right? So we run this. Now, how do we get? The first thing we do is, how do we get a specific element, right? Get a specific element in matrix. So to make this make sense or obvious, we know that we can frame this to the screen, and then we can say we want to print A. We know how to getting element locations in matrix. We know that 1 is in position, it is in row 1, column 1. So that is and then the code is row comma column. So getting element is of this sort. We know that it is row comma column number. So now to get an element in the matrix A, if we say 1 comma 1, now what is this going to give us? We expect 1. Oh, sorry, it's supposed to be 0 now. 0 comma 0, 0 comma 0. We know that we get 1. So for 9, why did we get 9? This is column 0, and then this is column 1. So it means that for column 1, the first element is in 0, and then the second element is in 1. So when we say A1 1, that was why it selected 9 there. And then if we say A2, still in the second row, but position 2, which is 10, so we should get 10 here. should get 10. So that is how we get a specific that is how we get a specific element. And then if we want to get 7, we know how to do that. We are going to say row 0 comma 6, and then that is how we get 7. Alright, so another thing is how to getting a specific row, and how to get that is should be straightforward already, but we have something like 0 and then you get column. So if you run this, we are going to be getting the first row, and then that is going to be the first row. And then if we want to get the second column, the second row, we make it 1, and then we get the second column. So now that's the specific. So now to get a specific column, how do we do that? We know that this is specifying a specific column, and then this column means that you get all the elements in that column. So it means that to get rows, get the rows in that column, get the column in that row, sorry. So now to get a particular column, it means that we get all the rows and then we single out the column. So if we want to get the second column, which is 2, 9, what is it going to be? So it means that we swap this. Want to get all the row, and then we specify the column, and then we get print this. Okay, we print this, which is 2, 9, and then if you want to get the last one, it is going to be it's going to be 6. Exactly. So what else can we get? So that's that about getting specific row and column. So now we can go a little further or do things that are more fancy. And then let's talk about 3D. Now we've spoken about 2-dimensional array, 1-dimensional array. Well, let's get cheeky and talk about 3D dimensional arrays or matrices. Right. So we know what we've been working with so far is still this, nothing has changed. And then for this we describe, it means that we are going to describe something that looks like this, a giant curly braces, and then we are going to define three rows like this, and then we are going to fill it with elements. So I advise that, so just make it make sense to make sure you don't do mistake. You can tab it like this to make it things obvious out, and then you can say point C, and I have this printed, and then we see that this is 3 by 3 matrix, which is a 3D matrix, right? And then in this we can also go ahead and get specific rows and column, and then to do that just follow the approach, the precedence we have set. Get a specific row, still the same thing. See, we know the first thing is row, so the whatever we want to get is what is going to be changing. So to get the second row we have 1, and then we get all the rows. Then once I print this we get the second row, and then to get first we have this. Then to get the third we have this. Okay, to get the third we have this. Right, and then the same thing we have done for a column still applies. And then we can say column, and then we can switch this number here. Then we are getting the last one, 369. And then to get a specific element, now we know that we have to deal with 3 points now, because it is 3-dimensional. So to get 5, we know this is the first row is 0, comma column, which is second column, 1, and then so we have gotten, so it's going to be 1, then 1, then for 5 is going to be 1. Now let's see what we have. Okay, let me see, what am I doing wrong? Too many indices for array is 2-dimensional, but it's 2-dimensional but 3 were indexed. Okay, so let's 1, 1. Alright, 1, 1 is, oh sorry, yeah, so 1, 1, that's 5. And then to get, say we want to get 6 now, still we get exactly the row is still 1, so this is 0 row, this is 1 row, and then the element in the second is in the second row, and then it's in the last column. So we still have 1, but it's going to be now 2. Then we get 6. So that is how we get a specific element in here. Get a specific element. Yes, please go on.
How can we go about if we want to get number 2, 6, and 7?
2, 6. Just
To
give
pick
me
one number from different places.
give me the number of the cell. Is it 43 or 44? What is it? Can you hear me?
I'm talking about this row and column that we are talking about.
This one I'm highlighting.
The one we are talking about right now. So how can we get number 2, 6, and 7?
2, 6, right, and 7.
6
Right.
and 7.
So now we want to get 2.
Yeah.
So say we want to get 2. We still have C. And then 2 is in the first row, and then the first row now is row 0. So it is 0, comma, and then it's going to start from 0, 1, and then is in the second column, which is 1. So this will give us 2. And then to get 6 is in row 1, because the first row is 0. You start counting from 0, and then the first row is 1, the second row is 1, so it's going to be 1 now instead of 0. And then if you get this, you're going to get the whole row, but you want to get 6, and that's 0, 1, 2. So So you put 2 in here and then you get 6. And then to get 9, all you have to do is just change this to 2 and then you get 9.
But can we run all the three on one straight line?
You, yeah, sure you can. I mean, why not?
Do you get sir?
You can do primes. Then you can change accordingly. This is what you're talking about, is that correct? Can you hear me? And of course you can change all of this back to row 1, row 0, then 1, and then 6 is in 1, and then 2, and then this is 6. You can get everything. It's good. Okay, so now we are going to move forward. So say we want to replace, and also go ahead and then replace element or change value. So we've seen what our C matrix looks like. But say we want to change 5 to 10. So how do we do that? How do we change 5 to 10? How do we change a specific element, replace a specific element? Change a specific element.
Hello. Sorry to take you back. Hello.
Hello, I can hear you.
Okay, line 55.
55. Okay.
If what Ayo just asked now, if you want to put it on a single row, this is on a column, can we just separate this parenthesis with a comma? Maybe like print C, open curly, 0, comma 1, close the bracket, is a separate comma, open the bracket. Can we just put the entire thing on a single line?
On a singular, like as like a row, like what we have here.
Like a row, fantastic. The answer should come in a row. Can we just separate it with a comma, like putting it one line after the other? Can we just separate it? Maybe print C, central bracket. We now bring the second one to the front of the first command, and it will be a single print, and the C. Can we do that so that we can have our answer 269 on a single row?
Oh yeah, I mean that comes to just manipulation. So let me say I have an idea now. So if we say
Okay.
this,
Yeah, yes. Okay. Yes. Okay. Separated by a comma. Okay.
then we have this.
Okay. Fine. Okay. That's what I want to ask. Okay. That's okay.
But
Thank
all of these things that are printed are just describing what the value is. I mean, they don't less mean
you.
that
Yes.
we could also do print to print the
Print
actual value.
Okay.
Then if I print this, the first is going to change to 2, and then if I do the
Mm-hmm.
second,
Print That's what I'm trying to ask.
yes, we can do it.
Without. Okay. We can do that. It's this command. Okay. Then we'll print.
Surprisingly. Oh,
So can do
okay. So the problem with it this is, I think print always puts a separator to be new line, so we can change that to a comma,
Okay.
and that is where we're
Okay.
getting.
To do with the other one, comma. Okay.
I don't know what's going on. Is this the separator now? Separator. But essentially we can do what I did earlier. This is coming with the un, unexpected issue. One moment first. But yeah, that's an interesting question. But usually when you print something, print with put a new line like this. Automatically by default that is what it does, and that's why this is coming out. So but we know that when we remove print we have something like this. So I'm trying, and I know that you can update the argument, but I'm not sure about the actual. Okay, let's do let's do this. Let me see if this works. Okay, so just don't I don't know how to make this work, but maybe just don't use print for now. Without print I think we're good to go. Yeah, this makes sense for now. Yeah. Okay, so now we have C, and then we want to change 5. So the question is, how do we change 5? And we know that we can get 5 by using this notation of getting a specific value. So I have 5 is going to be 1 comma 1, so that if we run this we get 5. And then now we want to change 5 to 22, and then we run this. Now if we check C again, we see that 5 has been updated. And then the same thing applies for rows. The first thing is you want to change a specific row. You have to be able to select the row first. So if we want to change the first row, we select the first row first, and then that is going to be row 0. Select all the values. The moment you can accurately do that, then you are good to go. Just update what you want to update it to appropriately, and then NumPy is going to do the update for you. Right. Now I have another option. So do we go to another thing, or we should just ask questions here? So if we have any questions so far, let's ask the question. So I'm going to give us a bit of a time to think about everything we've done so far. So in 2 minutes time I'll just continue if nobody has a question, or let's say 1 minute time.
Sorry, sir.
Yeah, please go on.
Why are we having integer 64 before in line 62?
Line 62. Okay. Okay, all of
Yeah,
these things, right? So essentially just
yeah,
think
sir.
it as I've spoken in list. I spoke about type notations. So these are type notations. This is telling us that this is int 64. Let me see for a very easy way to explain this. So I said something about I've spoken about other other types are like int8 and int32. So what that means is that in your computer you have 64 bits, so this value is saved with 64 bits. So let me put this in better perspective. For 6, this is going to be, this in particular is going to be stored as zeros and ones. So if you find the binary of 6, that is 6 is going to be converted to 0 and 1. You have 0 1 1 0. So you have 0 1 1 0 0 1 1 0. This is 4 bits. So 4 minus 64, you have 60. So this is suffixed with 60 zeros like this. We have 15 minutes more. So this is suffixed with 60 zeros, and each in a group of 4 bits. So essentially what this means is you have an opportunity of saving values that can span the entire bit. So you can save 64 bits. Everything has to be 111. You know, when you have like so for instance you have this. So for decimal you have, for a 3-bit register, you can save, the highest number you can save is 7 for a 3-bit register. For a 4-bit register, the highest number you can save is 15 in decimal. So if you have a 4-bit register, it means that the highest decimal number you can save is, or the highest binary you can save is 111 when all the values have been flipped to 1. Do you understand? So for a 64-bit register, what is the highest value you can save in it? That is going to be, can hold 2 raised to power 64, that is different value of range. So that means that if you convert 64 to binary, so 64 to binary, of course, because this has now enter hexadecimal domain. I don't know if that is clear. I feel like I've said so much, but to simplify this now, for a int 8, this means that you have 8 bits, and what this looks like is 0000 space 0000, and this is just equals to 0, spanning to 1111,1111. Now, so 1 byte is, this is 1 byte, this is 1 byte, 8 bit is 1 byte. So and then the highest you can save in here, I think, is what is this to decimal? So decimal is 255 essentially, and I think that's 2 raised to power 8 minus 1, 2 raised to power 8 minus 1. So that's the range of value you can save in. So basically, the higher the number of bits, the higher the memory space that you have. So if I can save in this, I can say C 1,1. I can say I'm going to have a buffer overflow if I save number that I'm not supposed to be able to save in it. So but let me try my luck now. Say I want to save a number like that number is going to be higher than this. Let's say, I don't know if this is going to work, but let's see. So So too long to. So this is Python in too large to convert to C long. So long is a value, a type of value in Python. But let's be reasonable and do 255. This should work. Let's do 256. Should work. Then we can say this. So essentially, when you see things like this, it's just signaling to the limit of value you can put in in that in that memory space. Yeah. Any other question? We have limited time now. I'm sorry, I should have mentioned because you're probably wondering why am I talking about a lot of ones. That is how computers save values. They save every information in binary. So all of this, everything on my screen right now, um, every graphic on my screen is saved on the transistor on my computer as 0 and 1 somewhere. So this scanning that we are seeing as a graphics now, somewhere on maybe 1 billion resistor on my computer right now, or in a certain memory space somewhere, is recognized or saved, represented in ones and zeros. And of course, there are higher functions of that. We have like hexadecimal, octa, blah blah blah. They are just ways to make sense of all of these ones and zeros. But essentially, they are ones and zeros. Machine language. And it could have also been let's see now. So it could have also been I could have been explicit with this and say d type data type equals int 64, and then we'll still be good. And I could have also said that this is actually float 64, and then we'll still be alright. So we now see that it's 1.2.3. So this is just in essence describing what the type is, how this is represented in the memory space, especially in Python. Any other question? Okay, this is 7 already. So I don't know how many minutes we have left, but I'm not sure we have enough, like too many minutes. So we are going to continue this in the next class and do some more complicated stuff. So there are matrices, operation like determinants, multiplication, all of that, and some linear algebra operations that we can also perform with using NumPy. So we are going to delve into that, and then next Saturday, God willing, if you are able to finish that in one class, next Saturday we'll perform some data cleaning operations. So thank you everyone. Thank you for coming. See you all next week. Did I just describe?